Team, it's Mr. Z, and today we're going to review some of the key things we've learned along the way in Math 3. Last time we looked at a bulletin board and we basically found the area of a shaded region. Now we're going to do a mixed review. Let's go ahead and dive on in. All right, in number 2, kind of like number 5, you want to make sure everything's on the left side of the equation. So when you're looking at it, for example, number 5, I see that it's in standard form. Booyah, good to go. I can use the quadratic formula, I can factor. So number 2 requires a little bit of a setup though. In number 2, you're going to notice that the negative 3 is on the other side. So I'm going to go ahead and use the inverse to add 3 to both sides, and I'm going to be careful not to combine negative 7x and 3. I'm going to write in order 2x squared, then I'm going to go to the degree below it. Well, that's going to be negative 7x, and then there's going to be this plus 3. So what is it going to be equal to? 0. Notice now it's ready to go. This unlocks the zero product property. We are ready to go. We need to find a product though. So part 1 of the zero product property is, do I have it equal to 0? Yes, unlocked. Product, aka I need to factor. So let me draw my area model to use to guide me. I always put the first term in there, 2x squared. Put the last term, 3. And then I have to figure out what multiplies to be equal to 3, but it has to add up to be negative 7x. So these two squares have to be negative 7x. I'm going to ask myself, what multiplies to be 2x squared? Well, I can try. I know 1 times 2 is 2, and I know x times x is x squared. This is a possibility. The area of that yellow square is created by 1x times 2x. Likewise, I'm going to go ahead and try 3 and 1. Both of them are positive. Positive 1 times positive 3 is going to be 3. So now, to see if this is going to be the factored version, I'm going to have to multiply out my square. This is going to turn into 1x squared, and then this is going to turn into 6x. Notice, team, looking at my area, the inside, when I combine them, it shouldn't be 1x squared, my bad. One times 1x is 1x. 2x squared plus 1x plus 6x plus 3. When I combine like terms, it becomes 2x squared plus 7x plus 3, which is almost what we want. Notice here, my b value is negative 7, not positive 7. So this means I made an error factoring. I'm going to go ahead and rethink about how I multiplied it out. So I'm going to erase the insides. And then I'm going to also erase my factors. So I got to think, what multiplies to be 3? What makes a negative number? Well, the only numbers that multiply to be 3 are 1 and 3, and I did get 7. So I really did like putting the 3 and the 1 here. But I'm going to do a trick and make them both negative. I'm going to remember that a negative times a negative is a positive. This is going to have the effect, when I multiply it out, is going to turn it into negative 1x, negative 6x. This minor adjustment is going to be what produces 2x squared minus 1x minus 6x plus 3 is going to be negative 7x. So this is the deal. This is interchangeable. Let me draw my arrow. interchangeable with 1x minus 3, 2x minus 1. Notice, I can switch this for this. They are equivalent expressions. So, what I'm going to do to solve this equation, I have my 0, I have factored. I'm going to rewrite it as my factored version. 1x minus 3 times 2x minus 1 equals 0. I know this multiplies to be the equation in standard form that is above it. I am going the inverse. I am figuring out what happened before in order to do the zero product property. Now, all that's required is for me to figure out when this is 0 and when this is 0. Case 1, case 2. Case 1 is when 1x minus 3 is equal to 0. And then I go ahead and use inverses, and it's going to be 3. Case 2, I'm going to have 2x minus 1 equals 0. And then I'm going to add 1 to both sides. Now, to get the x by itself, I have to divide by 2, leading me to the fraction 1/2. My solutions are x is 3 and 1/2. Okay, so number 5 is going to be very similar. I can also use the quadratic formula for any of these. 4, let's go ahead and do 3. Determine each key feature. Now, I am giving you a gimme. You are supposed to recognize that this equation is in vertex form. And you should know that this is the information you can get without graphing it, without using technology. Why? Because it's vertex form. Make these connections. Vertex form is always the output. The f of x is the same thing as y. A times x minus h squared plus k. So, concavity, I always know concavity has an A. Ooh. Concavity A. What is the A value? A is equal to -3. Okay, now this is the connection. Since it's negative, it is going to be concave down. Now, what this means, concavity down, means that it's going to look like an upside down quadratic. Remember, quadratics keep on going. And what you know is that the vertex, which is going to be right here, is going to be at the location HK. And we know it's going to be a maximum because it's the point at the very top. The vertex is HK. It's expected that you just remember that. And the reason why is when you compare in vertex form, H, K, so I know the vertex without graphing is going to be 7, -9. You can imagine that it is plus minus 9 if you want to make sure it's an exactly. You might have to watch out if it's something else on the inside. If it was, for example, x plus 7, you would have to rewrite it as a double negative. But really, team, x is near the x, or h is near the x. Now the axis of symmetry. The axis of symmetry. If you want to just memorize, it is always going to be x is equal to the h value. And the way I remember it is the h is in the spot of the coordinate. A coordinate is xy. For the vertex, it is hk, but it's still in the x spot. This is the y spot still. So the answer to this guy is literally just x equals 7, done. What that means is it's basically describing the line that cuts